That is the homework for multiplying polynomials. So let's go ahead and hop straight into HRW. And looks like the very first question we run into is the dimensions for a rectangular prism are x plus 8 for the length, x plus 9 for the width, and x for the height. What's the volume of the prism? So we've got x plus 8, x plus 9, and x. And we remember that when we're doing multiplication, that we can distribute straight through, and that the formula for the rectangular prism's volume, basically this is just a fancy way of saying a box, is length times width times height. So let's go ahead and multiply this x through here, and we're going to get x plus 8, and x times x is x squared. X times 9 is 9x. And then I am going to use the FOIL method for this. Since this is two binomials, FOIL will be a little bit easier than using either of the two methods we looked at in class, but you should remember this. So the F stands for first. X times x squared is x cubed. O stands for outer. X times 9x is 9x squared. I is inner. 8 times x squared is 8x squared. And L stands for last. 8 times 9 is 72. And it's an x, so 72x. When we FOIL properly, the middle two will combine. So we've got x plus 3. Then 9x squared plus 8x squared is 17x squared plus 72x. So that gives us x cubed plus 17x, would help if I got out of there, plus 17x squared plus 72x. Alright, number 2. Perform the following polynomial multiplication. So I have 7x squared, 5x, negative 1. I have 8x and negative 5. I'm going to go ahead and use the box method on this one. Eight x times 7x squared is going to be 56x cubed. 8 times 5 is 40. X times x is x squared. 8 times negative 1 is negative 8x. Negative 5 times 7 is 35. X squared. 5 times 5 is 25, but it's negative x. And then negative 5 times negative 1 is 5. So I've got 56x cubed. Diagonals, I've got 35. Sorry, this should be a negative 35 had I been paying attention to this negative 5. Negative 35 and 40 is 5x squared. Other diagonal, negative 25 and negative 8 is going to be negative 33. And then just tack on my plus 5 at the end. So 56x cubed plus 5x squared minus 33x plus 5. Perform the following polynomial multiplication. This time it is a 3 by 3, so once again I'm going to use the box method. I think it works a little bit easier, except I'm lying because this is x cubed and this is x squared, so we have different points here, and that makes the box method a little bit less not accurate, but a little less easy. So I'm actually going to use the double rainbow method or the grouping method. So I've got x cubed plus 9x squared plus 1. Then I've got 4x squared plus 7x minus 7. So the way this one works is I just take the first number and I multiply it by each of these, then the second number, multiply it by each of these, third number, multiply it by each. So x cubed. So this is 4x to the fifth, because cubed and squared. And then I've got plus 7x to the fourth, minus 7x squared. X cubed, sorry. So 9 times 4 is 36, and that is x to the fourth, because squared and squared makes 4. 2 plus 2 is 4. 9 times 7 is 63. That's going to be x cubed. And then 9 times 7 is 63, and that's going to be x squared. Then I've got, since this is just a 1, I can just rewrite each of these. So this is plus 4x squared plus 7x minus 7. Alright, so I only have a single x to the fifth, so that can stay by itself. X to the fourth here, x to the fourth here. 7 and 36 is going to be 43. To the third and to the third, this is minus 7 plus 63. So 63 minus 7 is going to be 54. I've got a couple of x squareds, and 63 plus 4 is 67. And then plus 7x minus 7 at the end. For x to the fifth plus 43x to the fourth plus 54x cubed plus 67x squared plus 7x minus 7. Apparently we made a mistake. Let's go back and double check. I've got 4x to the fifth, 7x to the fourth, 36x to the fourth, and 7 and 36 is 43. Okay. That's not a 1, that's a 7. 7x cubed, there it is. Okay, and then 9 times 4x squared is 36x to the fourth, times 7 is 63x cubed, and then 7 times 9 is 63x squared, and then 4x squared, 7x minus 7. Okay, so four x to the fifth, here's my fourths, yeah, I'm not sure where our mistake is here. So x to the fourth, x to the fifth, x to the fourth is 7 and 36 is 43. 63 minus 7. That is 56. And there's our mistake. You guys will notice that we didn't make a mistake in setting it up, but anytime I make a mistake, personally, it's almost always going to be in the arithmetic. And apparently that's not the only mistake I made. (63x squared plus 4x squared is 67x squared. 7x minus 7. So apparently I get to redo the problem completely because I made a mistake somewhere and I can't find it. So we've got, I'm going to use the box method this time, x cubed, 0x squared, no, 9x squared, 0x, 1. I can leave the cubed out here, so 4x squared, 7x, negative 7. Alright. So 4 times 1 is 4, x squared, x cubed is x to the 5th. 4 times 9 is 36. X squared is x to the 4th. 4 times 0, this is just going to be 0. 4 times 1, 4x squared. 7 times 1 is 7. X times x cubed is x to the 4th. 7 times 9 is 63. 63x cubed, 0, 1 times 7x is just 7x. 7 times x cubed is 7x cubed. That's a negative though. Negative 63 x squared. There's the mistake. That should have been a negative 63. Let's go ahead and finish out the problem now. 0, negative 7. So I've got 4x to the 5th. On this diagonal, 36 plus 7 is 43. X to the 4th. My cube diagonal, 63 minus 7 is 56. X cubed. My x squared diagonal is negative 63 plus 4, which is actually negative 59 x squared. Then I've got my plus 7x on this diagonal minus 7. So that was my mistake right there. So I made two mistakes, both of them basic arithmetic. So it's minus, and instead of 67, it's 59. And I have learned my lesson, so I'm going to go ahead and do this in a box as well, because it's much easier to find your mistakes when you're using the box method. 3x squared, 8x, 2. X squared, 2x, 3. So that is 1 times 3 is 3, x squared and x squared is x to the 4th, 8x cubed, 2 times 1 is 3, or 2 plus 1 is 3, sorry. 2 times 1 is 2, and just the x squared. 2 times 3 is 6, 1 plus 2 is 3. 2 times 6, 2 times 8 is 16, 1 plus 1 is 2. 2 times 2 is 4. 3 times 3 is 9. 3 times 8 is 24. 3 times 2 is 6. So I have 3x to the 4th. Then 8 plus 6 is 14. X cubed. Then 9 plus 16 is 25, plus another 2 is 27. 27x squared plus 24 plus 4 is 28, x plus 6. Alright, let's go ahead and use our other method, because you're going to notice that this one doesn't just have x's, this one has x's and y's, so we get to have a little bit of fun. We have 5x plus 7y. We have 4x squared minus 4xy plus 3y squared. So 5x times 4x, that is 20x cubed. 5 times negative 4 is negative 20, and that's going to be x squared y, because x times x is x squared, and then we've got to bring the y over as well. Then on our last one, we're going to have 5 times 3 is 15, x y squared. 7 times 4 is 28, x squared y. Negative 4 times 7 is negative 28, xy squared. 7 times 3 is 21, y cubed. So 20x cubed, and then I've got x squared here, x squared y, negative 20 and 28, so it's plus 8x squared y. Then I have 15xy squared minus 28xy squared. Well, that's negative 13xy squared plus 21y cubed. So 20x cubed plus 8x squared y minus 13xy squared plus 21y cubed. Polynomial multiplication. This time we just have x's. Let's use the box method again. X cubed, x squared, 0x, 3, x squared, negative x, negative 7. Okay, x squared and x cubed is x to the 5th, x squared and x squared is x to the 4th, 0, x squared and 3, 3x squared, negative x times x is negative x to the 4th, negative x times x squared is negative x cubed, 0, negative x times 3 is negative 3x, negative 7x to the 3rd, negative 7x squared, 0. Negative 7 times 3 is negative 21. So on our diagonals we have x to the 5th. This is plus 1, minus 1, so those are going to cancel. And I've got negative 8. Well, negative 7 minus 1 is negative 8, and the 0 is just 0. Negative 8x cubed. My next diagonal is negative x squared plus 3x squared. That's plus 2x squared. 0 minus 3x is negative 3x minus 21. So x to the 5th minus 8x cubed plus 2x squared minus 3x minus 21. X to the 5th, x to the 4th, 0x, 3x squared, negative, negative, 0, negative x, negative. I don't know how I just got 2 there. This is clearly negative 7 times 1. So negative 7x squared and 3x squared is negative 4x squared. It is kind of late while I'm filming this, so that could be part of it. However, much more likely problem is that I'm trying to do all this in my head, and I should be using scratch paper and a calculator because I'm just not that good at simple arithmetic. So we have 6x squared plus 5x minus 1. Notice that I'm being kind of inconsistent as to which one I'm putting on top and which one I'm putting down the side. It actually does not matter at all which one goes where. And the reason for that is because, if you think about it, 2 times 3 is 6, but so is 3 times 2. So the order that you write them in does not matter for multiplication. Regardless, 6 times 3 is 18, x to the 4th. 5 times 3 is 15, x cubed. Negative 1 times 3 is negative 3, x squared. 6 times 8 is 48, x cubed. 5 times 8 is 40, x squared, negative 8x. 6 times 5 is 30x squared. 5 times 5 is 20x, negative 5. On my diagonals, I have 18x to the 4th plus 50, 63. 15 plus 48 is 63. X cubed. 30 plus 40 is 70. Minus 3 is 67. X squared, but this time I saw my mistake, which was I forgot my plus sign. 20 minus 8 is plus 12x minus 5. Six times 3 is 18. 3 times 5 is 15. 3 times negative 1 is negative 3. 8 times 48, or 8 times 6, 8 times 5 is 40, plus 8 is 48. Okay. 5 times 8 is 40. 8 times negative 1 is negative 8. 5 times 6 is 30. 5 times 5 is 25. 5 times 5 is 25, guys. 25 minus 8 x 17. So it should be 17x. Businessman models the number of items in thousands that his customers' company sold from 1998 through 2004 as n equals this, and the average price per item as this, where x represents the number of years since 1998. Enter a polynomial that can be used to be modeled the total revenue for the company. So effectively, if you think about it, if I have one item and it costs $2 and you buy 3 of them, then 2 times 3 is how much you spend in total, which is $6. So the revenue that you make is how many items you sell times the amount that it costs. So if I can find the number of items and the average cost and multiply them together, well, they've given us both of those. It's negative 0.1 x cubed x squared negative 3x and 4. And then the average price per item in dollars is 0.5x and 7, where x is the number of years since 1988. Okay, 0.5 times negative 0.05 x cubed. This is 0.5x, not cubed anymore, x to the 4th. This is x cubed. 0.5 is negative 1.5 x squared, and that's 2x. 7 times negative 0.01 is negative 0.7 x cubed. This is 7x squared. This is negative 21x. And this is just 28. So, my model is negative 0.05x raised to the 4th power, then 1/2 minus 0.7 is negative 0.2 x cubed. Positive 7 minus 1.5 is 5.5 plus 5 plus 5.5 x squared minus 21x plus 2x is minus 19x plus 28. And they didn't ask me to find a specific year. Yes. Biologist has found that the number of branches on a certain rare tree can be modeled by the polynomial 7y squared plus y, where y is the number of years after the tree reaches a height of 7 feet. Number of leaves on each branch can be modeled by the polynomial 7y cubed plus 8y squared plus y. Enter a polynomial describing the total number of leaves. Once again, if I have 4 leaves per branch and I have 2 branches, then I have 8 leaves because I just multiply them. So if I multiply these two, I'm going to have 7y cubed 8y squared y. I'm going to have 7y squared and y. 7 times 7 is 49. Squared and cubed makes 5th. 7 times 8 is 56. Squared and squared becomes to the 4th. 7 times 1 is 7. Y squared and y becomes y to the 3rd. 7 times 1 is 7. Y and y cubed becomes y to the 4th. 1 times 8 is 8. Y and y squared becomes y to the 3rd. Y and y becomes y squared. So on my diagonals, I have 49y to the fifth, and then 56 plus 7 is 63y to the fourth. 8 and 7 is 15 y cubed, and then I just have y squared. Number 10. To evaluate the following polynomial, or evaluate the following polynomial using one or more of these identities. Oh, okay, so these are just identities. We haven't gone over these in class, but these are well-known polynomial identities. If you have a number plus another number, and that is squared, then that equals the first number squared plus 2 times the first number times the second number plus the second number squared. By the same vein, if you have a number squared minus a number squared, notice that there's no parentheses here. That is one number plus the second number times that number minus the second number. They have it written the other way on the screen. And finally, this was a sum. You can also have the difference squared. And for this one, you're just going to reverse this number. So you have x squared minus 2xy plus y squared. So effectively what they're saying is, if I have 84, well, for me personally, 90 is an easy perfect square, and 90 minus 6 equals 84. So if I were to take this, that would be, they want us to not do this, so I can replace 84 with 90 minus 6. That means that 90x squared, sorry, not 90x squared, 90 is x, so I plug in 90 for x, minus 2 times 90, and I plug in 6 for y. And then I have 6 squared. Okay. The reason I said 90 squared is easy is because 9 squared is 81, and then since it's just 9d, you just add 2 zeros at the end of it. 9 times 6 is 54. So add a 0 to that, that's 540. Times 2 is 1080. So minus 1080. And then 6 squared is just 36. So 8 minus 1 is 7. So that's 7020 plus 36 is 7056. So without a calculator, instead of doing 84 times 84, which could take a while, if you can find an easier combination, you can get your 84 squared. So this is just the same thing where they want us to do that. This time we'll just use 70 and 1. So this is going to be a sum. So 71 squared is the same thing as saying 70 plus 1 squared. And the sum formula is the same one that we just used. It's 70 squared plus 2 times 70 times 1 plus 1 squared. So the reason I chose 70 and 1 is because 1 makes all of this very, very easy. 7 squared is 49. Once again, since we have a 0, we just add 2 zeros to the end of it. 2 times 70 is 140. And we don't have to worry about this because multiplying by 1 is just the same. And then 1 squared is 1. So That's 50. $5,041.71 squared. Same thing here. And I think the easy way to do this one is going to be 78 squared equals 80 minus 2, because 80 is another relatively easy one. So that would be 80 squared minus 2 times 80 times 2 plus 2 squared. 80 squared, 8 squared is 64, add our two zeros. 2 times 8 is 16, times 2 is 32, so this is minus 320 because we have to add the 0. 2 squared is 4. So minus 320 is going to be 6080, plus 4 is 6084. This is going to be 60 minus 2, 3600 minus 2 times 60 times 2 plus 2 squared, which is 4, 3600 minus 12240 plus 4, 200 would be 4, so this is 3360 plus 4, 3364. Hopefully you guys can see that this is a heck of a lot faster than trying to do the long multiplication for 58 times 58. Hmm. 35 times 17. I don't know why they're asking us to solve this using one of the identities. I don't see the relevance here. However, I can tell you the easy way to do this is, wait, no, that's not what I'm doing either. I'm actually going to use an identity they didn't put on here. So I'm going to take 35 times 20 and subtract 35 times 3, because 20 minus 3 is 17. So 35 times 20 is 35 times 2, which is 70, add a 0. And then 35 times 3 is just 35 plus 35 plus 35. So that's 70 plus 35 is 105. So that would be 600, 595. I can do the same basic thing here. Well, actually, 16 is 4 squared. Is that where they're going with this? No, it's not. I really don't know a faster way to do this one than just the multiplication, which is 36, 12, 15, 0 spacer, 6, 2, 6, 11, 4, 16. I don't know a faster way to do that one. I'm not actually sure what they're looking for there. Alright, Wildcats, that is 4.2's homework assignment. Hopefully it doesn't take you too long. Hopefully it's not too difficult, because we are going to be taking our test on this relatively shortly. It'll be over addition, subtraction, and multiplication. But as you guys have probably noticed, you've been adding, subtracting, and multiplying for years. Just go a little bit slower than I did. Don't make the simple arithmetic errors that I was making, and you guys should be absolutely fine. Good luck, Wildcats.